Okay, so what is a proof? This week we're going to talk about the concept of what is a proof and go over different proof techniques, focusing largely, giving you a quick overview of several different ones, but we're going to focus largely on the concept of inductive proof, which is very common in discrete math and will be a major tool for the rest of the course. So what is a proof? A proof is, I'll type this up. A proof is an argument composed of a finite number of inferences that logically guarantees a conclusion. So the most common thing, most of you will have a history of doing these in your high school geometry courses, but probably nothing since. So most of you guys will have had a history where you do statement in one column and then reason in the other column, and then you get to your conclusion, providing your justification over here, either in terms of an axiom or in terms of axioms, theorems, already proven theorems, and also postulates or things that you've already proven along the way here. In theory, any proof could be written in that form or in the form of propositional logic. I should put that as proposition or symbolic logic. So symbolic propositional logic, you'll see something written like P implies Q, P therefore Q. So this statement says, or this is our first premise, this is our second premise, this is our third premise. So you can say, if you are Greek, then you are a man. Aristotle is Greek, therefore Aristotle is a man. Or human. You can also have it of the form all P are Q. That's all Q are Q. Let me change it. All P are Q. That P is a subset of Q. A is an element of P, therefore A is an element of Q. So a type of one classic argument where this comes up is all men are mortal, Aristotle's a man, therefore Aristotle is mortal, where this would be the collection of humans, this would be the collection of mortal things, things that die. A would be Aristotle. Aristotle is human, therefore Aristotle is a mortal. I jumped the gun. So to translate that into, we aren't normally going to be that concerned with getting these things in symbolic logic. Symbolic logic is nice because it's very clear how you are progressing from one step to another, and you can be sure that you're progressing correctly based on just a collection of rules of inference that we've had since Aristotle. But it's also not that nice to read, and we're going to want it to, most of our proofs are going to have a much more natural feel to them. So they're going to be written in much closer to plain English. So the classic example would be, like I just said, all men are mortal. And therefore Aristotle. That just means therefore. And this is short enough where we can basically just break it into premises. And we can see that, hey, this guy, Aristotle's mortal. This guy clearly follows from the other two. And you also have to make sure that you are using all of your, or that your definitions are consistent across here. So if you wanted to do Greek is a language, Aristotle is Greek, therefore Aristotle is a language, that doesn't work because you just changed the definition of Greek. So you have to make sure that your vocabulary is being used consistently throughout. So this basic breakdown is used outside of just math. Math is going to be the area that we focus on the most. This guy right here is Aristotle example is kind of the go-to intro example in philosophy, but there's lots and lots of other ones. You can do ethical arguments. Killing people is always wrong. Death penalty. Kill someone. Therefore, the death penalty. The big thing in philosophy is you will dispute the premises. So this guy will be something that's very hotly disputed. The second one is not going to be that hotly disputed, but will come up a lot. But in philosophy, you'll often dispute the premises, but this is of clearly logical form. And you'll get you'll have hotly debated things in, say, philosophy of religion, where you could have an argument for the existence of God, of if moral values exist, then God exists. Moral values exists. Therefore, God exists. You can also, and this is a perfect logical form. If P, then Q, P, therefore Q. But philosophers will debate very heavily these two premises. So this would be a logical argument, but not a proof, because these two statements are not self-evident. They need to be argued. Similarly, if you were to do an argument against the existence of God, say that the problem of evil, you would have, if evil exists, then a perfect God cannot exist. Evil exists, then the conclusion would be, therefore, perfect God. But again, these premises are going to be hotly debated in philosophy. versus in math, we will hopefully have, or we'll have premises that are indisputable. So I'm going to give you guys help on one of your problems right here. One of your homework problems. I think this is 9. So prove A intersect B complement is equal to A complement union B complement.